Hello, this is Mr. Stansbury. I'm going to take you through the 9H notes on Axes Intercepts. At the end of this, you should be able to say that I can find the x-intercepts and y-intercept of a quadratic function. Okay, so let's talk about what x-intercepts mean. So there's all sorts of different directions that you may see to find x-intercepts. One is find the solutions, solve for x, find the zeros. All of those are having you find the x-intercepts of a graph. Okay, and again, the graph of a quadratic is obviously a parabola, so it's usually going to hit in two spots. So there's really three different possibilities. Okay, so we have three different graphs. Usually you'll get your graph, it'll intersect in two spots. Once in a while it'll hit at just one spot if it just bounces off of the graph, and then once in a while it won't hit in any spots there. So that would be two solutions, one solution, no solutions. Okay, so let's jump into an example here, and it is example 24a from page 300. It says find the zeros of y equals 2 times the quantity x minus 3 times the quantity x plus 2. So we want this to equal 0. So we want to know when does 0 equals 2 times x minus 3 times x plus 2. Now again, for anything to multiply together to get 0, one of the terms has to be 0. So what you really want to figure out is, again, when does x minus 3 equal 0, and when does x plus 2 equal 0. So that would be when x is 3, or when x is negative 2. Okay, so your zeros of your quadratic function represented by this here is going to be at 3 and negative 2. All right, not that they are asking you to graph it, but if you were to graph it, just to kind of give you an idea, 1, 2, 3, there's 1 0, negative 2, there's your other 0. It is positive, so it opens up, so it's going to look roughly something like that. That would actually go through that point there. All right, so it's going to look something like that. We don't know exactly, but at least we kind of get an idea. All right, let's find the zeros of the x-intercepts. Oh, and the y-intercept as well. So find the zeros of the quadratic function. So we have this here, and we can try to factor this. And actually, if you'll take a look, you'll notice that all three of these terms have a factor of 3. And to make our life a little bit easier, I'm going to actually factor a negative 3 out, so our squared here ends up being positive. It just makes our life a little bit easier. So y is going to equal negative 3 times, and then that's going to just leave us with x squared, and that's going to leave us with plus x, and then 18 divided by negative 3 is negative 6. So y equals negative 3 times, this should factor out, and again we want to figure out what the factors of 6 that have a difference of 1 is, and that would just be 2 and 3. This sign here always goes with the bigger of the two factors, so that's going to be plus 3. And then this sign here tells us that the signs are opposite, because you have to multiply together to get a negative, so this here will be negative. So our zeros are when this equals 0 or when this equals 0. So our zeros are when x equals positive 2 or negative 3 are the zeros. Okay. This specific example here didn't actually ask for the y-intercept, but since that's one of our targets, let's find the y-intercept as well. So we found the x-intercepts, and we found let's take a look for the y-intercept. So if you think about it, when we have found already that we have a 0 here, and a 0 here, or the x-intercepts are here and here. Now we'll want to find the y-intercept here. So if you think about it, when we're looking for the y-intercept, everything all along this line, x equals 0. So all we want to do is plug in 0 for x, and we'll find our y-intercept. Okay? So y equals negative 3 times 0 squared minus 3 times 0 plus 18. That turns into 0. That turns into 0. So the y-intercept is 18. So let's change this to y-intercept is 18. Alright, so we found the y-intercepts, and then we also found the x-intercepts, or the zeros. Okay, so if we're going to graph this thing, it'd be way up here maybe. So that's going to be a real skinny graph. It's going to go way down like that, and way down like that. Okay, and it's kind of described with that with the negative 3x squared, so it goes down pretty fast. Alright, if you have any questions, feel free to ask. Thanks.